Good morning, or actually it's good afternoon. Okay, so the section we're in is, we're finally in the actual chapter, book 2, Calculus 2 book. And we're doing substitution, use substitution. And this is something that you learned at the very end of Calc 1. So you might have gone through it very quickly. So I want to go through it. So in this section, we're going to learn how to evaluate indefinite integrals using use substitution. And then we're going to learn how to evaluate definite integrals using use substitution. So I know that we went over the chain rule, but I just want to say a little bit more about the chain rule because we've been using it a lot. And it's real important to what we're doing, because being able to integrate, we're going to need to understand the differentiation process. Okay, so let's review the chain rule. So we said given a function y is equal to u of, y is equal to, let's say, y of u of x. Then in order to find dy dx, we take dy du and multiply that by du dx. Okay, so we've learned chain rule and we've been doing that for the last couple of weeks now. Okay, I need to send out an announcement about your exam. All right, so now we want to go backwards.
Recording in progress.
We want to go backwards. We want from taking from y, started with y, to finding its derivative. So that was the differentiation process. So now we want to do the integration process, where we start with dy dx and we go back and we find y. So this is the integration process. Now, the thing about this is we know how to integrate very simple things. All right, so the first rule we definitely remember. So let's recall this rule. So the things that we already know, okay, these are things that we definitely learned in Calc 1. So I'm going to need a little bit more space because I'm getting ready to write a whole bunch of rules. Okay, so the first thing we remembered or we learned was that when you integrate x to the n dx, you get x to the n plus 1, and it is divided by n plus 1. And this only works when n is not equal to -1. And the reason why is because we know that if we integrate 1 over x, which is what I'm getting ready to do next, the integral of 1 over x dx, we already know that's the natural log of x. Did I do that yet? What's the next section? Wait a minute, I may not have done that. Let me quickly check. I feel like I did it, but I'm not 100% sure. Integrals involving, we did derivatives. Okay, we didn't do integrals yet. All right, so let me take that off. I'm going to erase that because we're not there. Let's get rid of that because that's the next section. Okay. So instead, I want to do the trig ones because we know the trig ones. So we know that the integral of cosine of x dx. Oh, I want cosine kx. Just leave it cosine x dx is equal to sine x plus a constant, which I completely, when I wrote this, I said, I'm missing something, plus a constant, and not equal to -1. Okay. The integral of the sine of x dx is negative cosine x plus c. The integral of tan, we'll learn integral of tangent in a minute. We don't know integral of tangent. I'm going to teach it to you. I think that's as far as we can go. We know the integral of secant squared. We know that. We know that is the tangent of x. We know the integral of cosecant squared. And that's negative cotangent x. And we know the integral of secant x tangent x dx is secant x plus a constant. And lastly, we know, and if you're saying, I don't know these, then I think we need to get some, you need to do, again, 3x5 cards. Y'all think I'm kidding. Them things work. Flipping through those things every day, those things work. Integral of cosecant x cotangent x dx is minus the cosecant x plus c. Okay, so all these derivatives we know, and we can use these things somehow. We'd like to be able to use them. Okay, so now what happens if I want to integrate something and I need to use the chain rule? Notice all of these are integrals with just x. Okay, so use substitution. I need to be able to take all of these integrals and do the same thing with u. So we're going to go down the page. Okay. So the integral of u to the n du is u to the n plus 1 divided by n plus 1 plus a constant. The integral of the cosine of u du is negative. It's just, I don't know why I keep doing that. It's not negative. That one is the sine of u plus a constant. The integral of the sine of u du is negative cosine u plus a constant. So go down your page and switch everything to u. All right, so therefore, if I have, now I want to integrate something. So now I want to integrate to the integral of a derivative of a function of u of x, and then u prime of x is sitting right there. Its derivative is sitting right there. Then this now allows me, so this is the dy du part. And this part is the du dx part. I shouldn't have the, it should only go there, yeah. So this integral should just give me y back, which is whatever the function was, plus a constant. So if I can identify u and then integrate just the function with the derivative sitting next to it, I will get the most general antiderivative. So this is the most general antiderivative. All righty. Okay, so here I have the integral of x times the cosine of x. All right, none of this should look strange to you. Hopefully it doesn't. Okay, so for this problem, notice I am taking the cosine of x squared. So the outside function, the y of u, is the cosine. That's its derivative. And then that, so this is dy du. And then I have to find du dx. So now I am going to let u equal x squared. And then du is 2 times x dx. Now notice, what do I have in my problem? So if I go to rewrite this, this is the integral. The cosine of x squared I can write as the cosine of u. So what's still left in the problem? X dx is what's still left. So now I need to solve for that. So x dx, divide both sides by 2, is 1/2 du. So in the rest of the problem where I have x dx, that x dx is the other part of this problem. Because this was the cosine of u, remember u was x squared. And the x dx is what was left. X dx is now 1/2 du. So this becomes the integral of the cosine of u, and x dx becomes 1/2 du. Uh-oh, I went yellow. So this becomes times 1/2 du. So now I can move the 1/2 out and get the integral of just the cosine of u du. But when I integrate cosine, I just get sine. So this is 1/2. Cosine of u du becomes the sine of u plus a constant, which I now have to put u back in. So I get 1/2 the sine, u is x squared plus a constant. And there's my answer. Okay, let that sink in for a second. I seem to be lagging. Oh yeah, I really am lagging today. Okay, let's get the blackboard. So eventually I will take roll. Okay, I'm moving on to the next one. All right, so the next problem is the integral of 3x, and then I have 2x squared plus 1. So I have to be able to figure out what u is. So I want you, all of you right now, to write down what you think u is for this problem. I know we just started doing it, but this is review. So you should be able to start to try to get going on this. Write down what you think U is for this problem. And then I want you to find DU. If you can get that far, you're good. That's what I want you to do. Okay, here we go. So what did you get for U?
Is it 2x squared plus 1?
That's right. Okay, so U. Okay, so what'd you get for DU?
4x.
Okay, don't forget your DX. You need that. We're doing differentials. So you need 4x dx. You need the differential, okay? All right, so now if I go to this problem, I always take constants out because constants just can come out the problem right away. So this is the integral. Oh, I'm going to take the 3 out. Take the 3 out. I have the integral. I have x dx divided by 2x squared plus 1 cubed. So now I can see that this is 3 times the integral. X dx. Well, I can find x dx. X dx is right here. So if I divide both sides by 4, I get 1 over 4 du is x dx. So now I can solve for x dx. So x dx is simply going to be 1 over 4 du divided by, and this is 2x squared plus 1 cubed, so that just becomes u cubed. So now I have 3 over 4, the integral of du over u cubed. Now again, I told you I can only do this stuff with negative exponents. So this is 3 over 4, the integral of u to the negative 3 du. Okay, so now I'm going to go back to that first rule that we did, the integral of x to the n. There it is. Integral of x to the n is x to the n plus 1 over n plus 1. So this is going to be 3 over 4. I'm going to get the integral of u to the negative 2 because I'm going to add 1 to negative 3. Now I'm going to divide by negative 2. Plus a constant. Okay. So that's looking like negative 3/8. And then actually the u to the minus 2 is in the denominator. So I'm going to write that as negative 3 divided by 2 times u, which is 2x squared plus 1 to the squared, because that's what it is, the 2 plus a constant. So now I have an answer. Any questions?
I have a question.
Yes.
The 4 from the 3/4, what did we do with that?
It's supposed to be, this is supposed to be an 8. I don't know why I wrote a 2. It's supposed to be an 8. Okay. I took this 4 and multiplied by that negative 2. And that's supposed to be an 8. I don't know why I wrote a 2, but now it's correct.
Okay, thank you.
Does that make more sense?
Yeah, it does.
Yeah, thank you for finding that little typo there. That was a big typo.
Can you explain the last step again? I'm a little confused.
Okay, which last step?
Just from where your mouse is to the box.
From here to there? Okay,
Yeah.
no problem. So I'm gonna erase this for a moment because I'm gonna stick a step in. Okay, so this is the -3. You see the -3 over 8. And then u to the -2 is 1 over u squared. So u to the -2 puts u squared in the denominator. And then 3 is in the numerator, and -2 and 4 are in the denominator. So that gives me 8. Sherman, you see that step?
Yeah.
Okay. So then I said, well, this is -3 in the numerator. And in the denominator, I have 8 multiplied by u, and u was 2x squared plus 1, quantity squared, plus a constant. Okay. Tremont, I need to know you're okay with this before I go to the next
Oh,
problem.
yeah. Yeah, I'm good.
Okay, thank you. All right. All right, I'm going to let you guys work on this last problem here while I take a roll. All right, where are we on this problem? Who wants to walk us through it? Celine,
Yep.
okay,
So
go ahead.
the u would be 2x to the third power plus 4.
Okay,
And then the du would be 6x to the second power.
okay, don't forget your dx. You're gonna need it.
And, yep. And then to get dx, it's du over 6x squared.
All right. No, not 6x squared, just du over 6 is x squared dx.
Yep. Mhm.
Okay.
I was just gonna plug it back into the integral to cancel the x squared.
Oh, okay. Some people do that. That's okay. All right, go ahead.
And then you get square root of u.
So I get u.
Yeah.
The square root of u said,
Yep.
okay.
Du.
And x squared dx. That's what?
2x.
No, you have over here x squared dx is something else.
Oh, 1/6.
Yeah.
Sorry. And you're gonna put that.
Okay, so now we can pull the 1 over 6 out and we have the integral, and that becomes u to the what?
1/2.
1/2 power. Du. Okay, so 1 over 6. How do you integrate u to the 1/2?
So you're gonna add 1, so u to the 3/2,
U to the 3/2.
and then multiply that by 2/3.
Multiply by 2/3. That's where we divide by the top. Okay. So now we get
2 over 18, so 1/9.
1 over 9.
U to the 3/2.
3/2 power plus c.
Mhm.
And then what do we get?
You plug back u in, so 1/9, 2x to the third plus 4 to the 3/2 power.
That's perfect.
Right.
Thank you.
Yeah.
Okay, any questions? She walked us through that very nicely. Okay, so all of those problems we're dealing with indefinite integrals. Now we want to do a definite integral. Okay, so a definite integral is a little bit different because with the definite integral, we have to worry about limits of integration. Now, I had a student, Calc 2 student, who said to me, what is that 0 and 1? All right, again, right now, if you have no idea what 0 and 1 are, please text into the chat only to me. You don't have to send it to anybody else. What is 0 and 1? Because I need to know if you don't understand what that means. What this integral actually means. What does this integral actually mean? What is it? Why would we compute this integral? What does the definite integral actually represent? Anybody know?
Would it be from 0 to 1?
And what is it from 0 to 1? Okay, I have a few people. Good. All right, so a few people. Okay, so what this means is this is actually, by definition, this is the area under the curve of the function f of x equal to 2x over the square root of x squared plus 8 on interval.
I don't even want cereal right now. I don't know what I want to eat.
What are some things
Okay,
where you're
let me see. What I did,
even to us personally?
I can get this here. What is it? What's the function? 2x
Integral stuff is kind of hard.
x over. What's the matter with integral stuff? Okay, that won't graph it for me. Okay, so that's some function. Oh yeah, that is kind of right. That is the function. That was, it's pretty linear actually. So that's the function. And then there's, so whatever it is, there's some function, whatever the function is between 0 and 1, it's the area under the curve of that function. That's what definite integrals represent. Okay, so now to compute this, we're going to do it the same way, but we need a little bit more. Okay, so now we're going to compute this. So what is u?
X squared plus 8.
X squared plus 8. And what is du?
2x.
2x dx. Okay, any questions? All right, so now because we made the transformation from x to u, we also need to make the transformation from x to u on the limits of integration. So 0, remember, whatever this curve looked like, I'm graphing it from 0 to 1, and there's some function. But then we translate it into the u variable. So when I translate it into the u variable, I need to figure out what u is. So when x is equal to 0, u becomes the x squared plus 8 or u becomes just 8. And when x is equal to 1, u becomes the square, u becomes 1 plus 8, which becomes 9. Okay. So I have to move now. So that's what's different from this problem. These problems, I didn't have to find limits of integration. Now I do. So u has to transform to those limits. So now we're going to do everything. So let's see. 0 now becomes 8. And 1 now becomes 9. All right, so my limits of integration change. U becomes 8 and 1 becomes 9. All right, I still have this 2. So now this one's even more perfect. I have 2x dx. Well, you can't get any more perfect than that. So 2x dx just becomes du. And then this becomes u to the negative 1/2, u to the half, which is u to the negative 1/2 power. So this just becomes u. So I had u to the negative 1/2 power du. Check. Okay, thank you. Got you, Malcolm. I'll go back and change it. Okay, any questions about this right now?
I do.
Okay, yes, what's your question?
Just to confirm, the u to the negative 1/2, it changed to negative because it's in the denominator?
Yes, ma'am.
Okay.
So it's u, it was u in the u to the 1/2 in the denominator,
Yeah.
but in order to integrate it, I moved it to u to the negative 1/2 so I can use the power rule.
All right. Thank you.
You're welcome. Okay, any questions? All right. So now this becomes u to the 1/2 power, and I have to divide by 1/2, so I get a 2. And now I have to evaluate it. So I'm using the fundamental theorem of calculus. All right, I have to evaluate it from 8 to 9. So that means I have 2, I can factor the 2 out. I have 9 to the 1/2 power minus 8 to the 1/2 power, fundamental theorem of calculus. All right, so if you remember fundamental theorem of calculus, the integral from a to b of f prime of x dx is f at b minus f at a. All right, fundamental theorem of calculus. So what I did was I integrated found the most common antiderivative. And I used the fundamental theorem of calculus. If I integrate the derivative of a function, evaluate it from a to b, I just get f of a, f of b minus f of a. So when I integrated from 9 to 8 to 9 of u to the 1/2 du, I got 2 from the negative 1/2 plus 1 gives me 1/2, divide by gives me a 2, evaluated from 8 to 9. So that's the fundamental theorem of calculus. Okay, actually I can even add, I should have added a spot to it. For some people who really don't remember it, I'm going to add one more piece to it for you. This becomes, by definition, f of x evaluated from a to b. Let me add that in. So now that is f of b minus f of a. Okay, so let me just add that in so that for people who are like, where did she get that? Well, now you know. There's the fundamental theorem of calculus. Okay. All right, so we're almost done. All right. So this is the answer becomes 2. This is 9 to the 1/2 is the square root of 9 minus the square root of 8. So my answer turns out to be 2. 3 minus 2 to the root of 3. 2 to the root of 2. So that's the answer. So now notice that when we have limits, we don't get a function, we get a value. Because this value represents an area, so we get a value. Okay, any questions about that one? This one's a little tricky, not too bad, actually. All right, so I'm going to rewrite this. Well, actually, we can see u here is the sine of x, and it gets squared. Its derivative du is the cosine of x. How nice is that? Cosine x dx. So du pops out right away. Boom, bitty, boom, boom, boom. There's du. Cosine x dx. Okay. So now I need to change. So if x is equal to 0, u is equal to sine of 0, which is 0. And if, I should write that out. And if x is equal to pi over 3, u is equal to the sine of pi over 3, and that's just 1. Okay, so sine of pi over 3 goes all the way up, goes up here. That y value is 1. Okay, so let's transform my integral. I'm going to use u substitution. 0 becomes 0. Pi over 3 becomes 1. Sine squared becomes u squared. And cosine x dx becomes du. Oh, that was pretty. Look how pretty that is. Nice and smooth. Because the derivative is sitting right next to it. Okay, so I can integrate this. This becomes 1/3 u cubed. Evaluate it from 0 to 1. 1/3. So I'm going to get 1 cubed minus 0 cubed. Just being particular. So the answer is 1/3. Any questions?
Where do you get the 1/3 from? I'm sorry.
Where did I get the 1?
1/3.
Oh, because when I take, so the integral of u to the n du is u to the n plus 1 over n plus 1. Okay, so this is u, so that becomes u to the 2 plus 1 is 3 divided by 3. So that's where the 1/3 comes from, because I divided by 3.
Oh, okay. Thank you.
No problem. Okay. We still have time. Okay, here's the problem. Yep, that's what I want. Okay, so what is u in this problem?
X squared.
Yes. And so du is
2x.
dx. Okay, so if u is equal to 0, I'm sorry, if x is equal to 0, then what is u?
Zero.
Yes. And if x is equal to the square root of pi over 4, then what is u?
Pi over 4.
Good. Okay. So this becomes the integral from 0 to pi over 4 secant squared of u is this piece. That becomes secant squared of u. I have x dx left over. So x dx becomes 1/2 du. So now I have the integral 1/2, the integral from 0 to pi over 4 of the secant squared of u du. And what's the integral of secant squared? What's the integral of secant squared?
Is it tan?
Tangent. So I get 1/2 the tangent of u evaluated from 0 to pi over 4. So I get 1/2 the tangent of pi over 4 minus the tangent of 0. What's the tangent of pi over 4? Y'all should be flipping over that little card. It's right there on, flip it, tangent pi over 4. What is it?
1.
Yes. Tangent of 0 is 0, so the answer is 1/2. Okay. Any questions about this? Because tomorrow we're going to be doing integrals of integrals that involve exponentials and logs. Okay, so we're going to be doing that, and that'll be the last section that is on this test. Actually, I don't even know if it's on this test. I have to look. Okay. Again, if you send me email, please let me know whether you're in the 12 o'clock or the 1 o'clock section. I appreciate it.